Welcome to the Deep Dive. Today, we're diving into KEDA, a tool that's really changing the game for how applications scale in the cloud. We've got a ton of material on this that you sent us, so we're going to break it all down.
Yeah, it's a fascinating area and one that's becoming, really critical as more applications move to cloud-native architectures.
Absolutely. So before we jump into the nitty-gritty, let's just make sure everyone's on the same page here. We know you work with Kubernetes, which is kind of like this amazing conductor for your cloud applications. It keeps everything in sync. But just like a conductor, adjusts the orchestra based on the music, your applications need to scale up or down based on demand. And that's where KEDA comes in.
Yeah, exactly. KEDA stands for Kubernetes Event-driven Autoscaling. It's all about making those scaling decisions, based on real-time events, not just traditional metrics like CPU or memory usage.
Okay, I'm intrigued already. So why is just looking at that resource usage sometimes not enough? Can you give us an example of when an event-driven approach would be a better fit?
Sure. So imagine you have an e-commerce application, and it experiences these sudden spikes in traffic during a flash sale, relying solely on CPU and memory metrics. It might mean your application doesn't scale up fast enough to handle that surge in orders, and as a result, customers might experience delays or even errors, and you could miss out on sales. But with KEDA, you can configure it to respond directly to those incoming orders, triggering immediate scaling to ensure a smooth and responsive experience for users, even under extreme demand.
That's where KEDA shines. So it's not just reacting to how hard the system is working, but to the actual events that are driving that workload. And our research shows this can have a real impact on cost savings too, right?
Oh, absolutely. By scaling up only when needed, based on those specific events, you avoid over-provisioning resources. You're not paying for computing power that's just sitting idle. In fact, some companies have reported saving up to 70% on their cloud bills after implementing KEDA.
Wow, 70%. That's a compelling argument right there. But before we get too far ahead of ourselves, let's zoom in on how KEDA actually works. So we've got this open source tool. It's all about event-driven scaling. But what are the pieces that make it tick?
At its core, KEDA has four key components: the KEDA operator, scalars, scaled objects, and scaled jobs. Each of these plays a crucial role in making that event-driven magic happen.
All right, let's break those down one by one. What exactly is the KEDA operator doing behind the scenes?
Okay, so the KEDA operator, that's like the brains of the operation. It's constantly monitoring the event sources that you've defined. This could be a queue of messages, metrics from a monitoring system, or even changes in a cloud storage bucket.
So it's always on the lookout for those specific triggers, the ones we want to use to drive those scaling decisions. So what happens when the KEDA operator detects something interesting? Is that where scalars come in?
You got it. Scalars are the eyes and ears of KEDA. They are responsible for translating those external events into a format that Kubernetes can understand.
So each scalar is specialized to listen to a particular type of event source.
Precisely. There's a whole library of pre-built scalars for common event sources like Kafka, Azure Event Hub, or Prometheus. But you can also create custom scalars if you're working with a more unique event source.
That's a great level of flexibility. So the scalar picks up the signal, translates it, and then what? How does that actually trigger the scaling action?
That's where scaled objects and scaled jobs come in. Think of a scaled object as a blueprint that defines how a particular application should scale.
So it's like the instructions that tell Kubernetes how many replicas of the application to run, based on that incoming event data.
Exactly. And scaled jobs are similar, but they're used for batch jobs rather than long-running applications. The scalar feeds information into these objects, and that's what ultimately drives the scaling behavior.
This is starting to make a lot of sense. We have the operator watching the events, the scalars translating those events, and the scaled objects jobs using that information to tell Kubernetes how to scale. But how does all of this fit into the bigger picture of Kubernetes scaling? We know there are other tools out there, like Karpenter and the horizontal pod autoscaler, HPA. How is KEDA different?
That's a great question. It's important to understand how these different tools work together. Karpenter, for instance, is focused on scaling the infrastructure itself, like adding more servers to your cloud data center when you need more overall capacity. KEDA, on the other hand, is more granular. It scales the individual applications running on that infrastructure.
So Karpenter is like expanding the concert hall, while KEDA is adjusting the size of the orchestra within that hall.
Yeah, that's a good analogy. And then we have the horizontal pod autoscaler, or HPA, which has been the go-to scaling tool in Kubernetes for a while now.
Right. I remember from the material you sent that HPA is all about looking at those traditional resource metrics, like CPU and memory utilization.
Exactly. And it does a great job at that. But HPA is limited to those internal metrics. It can't respond directly to those external events that we've been talking about, like messages in a queue or changes in a database.
So where does KEDA fit in with HPA? Is it a replacement, or do they work together somehow?
They actually complement each other beautifully. Think of KEDA as an extension of HPA. It provides HPA with a whole new set of signals to work with. So instead of just looking at CPU and memory, HPA can now factor in those event-driven metrics from KEDA and make even smarter scaling decisions.
That's a really elegant solution. It's like giving HPA a whole new set of senses. But I can imagine that choosing the right scaler for a particular application and configuring those scaling thresholds, that could be a bit tricky. What are some of the challenges or pitfalls that someone new to KEDA should be aware of?
Yeah, you're right. There is a learning curve involved. One common mistake is choosing a scaler that isn't well suited for the event source. For example, using a CPU-based scaler, when you should be using a queue-based scaler, could lead to inefficient scaling behavior.
So it's really important to understand how your application behaves and what events are truly driving its workload. Are there any tools or resources that can help with that process?
Absolutely. KEDA has built-in tools for monitoring and logging that allow you to see exactly how your application is scaling and why. There are also some great community resources and best practices guides that can help you avoid common pitfalls.
That's good to know. It sounds like KEDA, while powerful, does require a bit of careful planning and configuration to get the most out of it.
Yeah, that's true of any powerful tool. But the benefits are well worth the effort. We've talked about the cost savings and the improved responsiveness for users. But there's another key benefit that's often overlooked.
I'm curious, what's that?
It's the ability to decouple your application logic from your scaling logic. With KEDA, you don't need to bake scaling rules directly into your application code. You can define those rules externally using scaled objects and let KEDA handle the scaling automatically.
That's a big deal for developers. It means they can focus on writing great code without having to worry about the complexities of scaling.
Exactly. It simplifies the development process and makes your applications more portable and easier to manage.
All right, so far we've explored what KEDA is, how it works, the benefits it offers, and some of the things to watch out for when implementing it. But we've only scratched the surface of the world of event-driven autoscaling. What else should we consider as we dive deeper into this material you sent?
Well, one thing that's really exciting is the potential for KEDA to integrate with serverless technologies.
Ooh, serverless. That's a hot topic these days. How would KEDA play into that world?
Imagine combining KEDA's event-driven scaling with the elasticity and pay-per-use model of serverless. You could have applications that scale down to 0 when there's no demand and only spin up when triggered by specific events.
That sounds incredibly efficient. No more idle resources just waiting around. You only pay for what you actually use.
Exactly. And this is an area where KEDA is actively being developed. There are already integrations with serverless platforms like Knative, and we're likely to see even tighter integration in the future.
So KEDA is not just a tool for today, but a platform for innovation in the world of cloud-native scaling.
Absolutely. And there's a lot more we can uncover in your research. Let's dive into some of the practical applications of KEDA and explore how it's being used in real-world scenarios.
That sounds great. Let's get specific and see how KEDA is making a difference for companies and developers who are pushing the boundaries of cloud-native applications. Okay, so we've talked a lot about the what and the how of KEDA, and now let's get into the why. Why are people actually using this, and what kind of results are they seeing?
Yeah, one of the most compelling use cases I've come across is in the world of image processing. Think about a company like Pinterest, where users are constantly uploading, millions of images. Using KEDA, they could configure their image processing pipeline to scale based on the number of images, waiting in a queue.
So instead of having a bunch of servers just sitting idle, they only spin up that processing power when there are actually images that need to be analyzed or resized or whatever they're doing with them.
Exactly. And that can lead to some serious cost savings. Plus, it ensures that images are processed quickly, leading to a better user experience.
Makes a ton of sense. It's like having an on-demand image processing factory that only turns on the machines when there's work to be done.
What other interesting examples have you seen?
Another great example is in the realm of IoT. Imagine you have a network of sensors collecting data from, say, wind turbines or traffic lights. Those sensors are generating a constant stream of data that needs to be processed and analyzed.
I can see where this is going. Instead of having a fixed amount of computing power dedicated to that task, you could use KEDA to scale those resources up and down. based on the volume of data coming in from the sensors.
Right, and you could even configure KEDA to respond to specific events, like a sudden spike in data from a particular sensor, which might indicate an anomaly or a potential problem that needs immediate attention. This is so cool. It's like KEDA is giving you this fine-grained control over how your applications react to the real world. But with all this flexibility, there must be some challenges. In terms of choosing the right scaler and configuring everything correctly, what advice would you give to someone who's just starting out with KEDA?
Yeah, my biggest piece of advice is to start small and iterate. Don't try to boil the ocean. Pick a single application or a microservice that can benefit from event-driven scaling, and experiment with different scalars and configurations in a non-production environment. See what works, what doesn't, and gradually build up your expertise from there.
That's great advice. It's like anything in technology. You don't have to become an expert overnight. Start with a small win, learn from it, and then keep building from there. And I know there's a really active KEDA community out there. That can be a great resource for folks who are just getting started.
Oh, absolutely. The KEDA community is fantastic. They're constantly developing new scalars, sharing best practices, and helping each other troubleshoot issues. It's a great place to learn and get support.
So it's safe to say that KEDA is not just this cool technology, but also a vibrant ecosystem with lots of momentum behind it.
Without a doubt. And as more and more organizations move towards cloud-native architectures, I think we're going to see even greater adoption of KEDA in the coming years. It's a tool that truly empowers developers to build applications that are more responsive, more efficient, and ultimately more resilient in the face of ever-changing demands.
Well, I think it's safe to say that we've given you a solid understanding of what KEDA is, how it works, and why it matters. But the real power of KEDA lies in its application. So, as you continue your exploration, remember to think about your own specific needs and how this technology can help you build better, more scalable applications.
And don't forget, the key to mastering any new tool is to get hands-on and experiment.
Exactly. So keep diving deep, keep learning, and keep pushing the boundaries of what's possible in the world of cloud-native development. That's all for a deep dive on KEDA. We'll see you next time.